Hi everyone, welcome back to the channel, and today we're going to solve Leetcode daily challenge problem number 1143, longest common subsequence. So this is tagged as a medium problem, and this is one of the easiest problem which you can use to learn dynamic programming approach. So we'll first check out the problem statement, then we'll look into the approach which you're going to use, and towards then we'll see the code as well. So starting with the problem statement, we have given two strings text1 and text2, return the length of their longest common subsequence. If there is no common subsequence, return 0. Okay, we'll get two strings text1 and text2. We'll have to return the longest common subsequence. Now they have defined a subsequence. A subsequence of a string is a new string generated from the original string with some characters. It can be none, deleted without changing the relative orders. Okay, so basically you are not allowed to change the relative orders, but you can basically remove a few characters from one of the strings. Okay, for example, A's and abcde. Okay, so the longest common subsequence will be of length 3 in it. Okay, now they have defined a common subsequence. A common subsequence of two strings is a subsequence that is common to both strings, of course. So as I said, like the subsequence or the longest common subsequence between A's and abcd will be 3, because you can get A from both the strings, and C is occurring after A in both the strings, and we have E at the last of both, right? So A's will be the substring, the longest substring between the two texts. So we will be using dynamic programming to solve this problem, and let's check out the approach which we'll be using and the logic that we're going to implement. Okay, so for dynamic programming, like you can assume that you have this grid. Okay, on one axis you have plotted text1, and on other axis you have plotted text2. Okay, now you have a very simple logic to implement. So what we will be doing is, if the characters are same, and by the way, like I'll be using bottom up approach, so I'll be starting with the last characters, and we'll work towards the first character. Okay, so what we'll be doing is, if we will have same character of on both the strings, we will take the diagonal element, and add 1 in it. Okay, otherwise that means that if the characters are not same, for example D and C are not same, then we will take the maximum of the row above, or the next column basically. So how can I, okay, this. Okay, so let's check out, let's just do a dry run of this example. For example, we started with this EE. Okay, the both the strings or both the characters were similar, so we had 0 at the bottom. So what we'll do, we'll add 1 in it. So now we have 1. We have D and E. This is not same, so we'll take the maximum of this or this. Okay, so it will be 1. Same with EC. We'll take maximum of this or this, which will be 1, and so on. Like all the elements will be 1 in this particular row. Okay, next comes C and E. Okay, the characters are not same, so we'll take maximum of this and this, which will be 1. Now we have C and D. Of course, again it is not same, so we'll take max, which will be 1, because both the values are same. Now we have C and C. Okay, the characters are similar, so what we'll do, we'll take the diagonal element and add 1 in it. Okay, now we'll continue the same. BC, not same, the maximum of this and this, which will be 2, and 2 here as well, with the same reason. Now we'll have A and E. So take the maximum of these two, which is 1. A and D, maximum of these two, 1. A and C, maximum of these two, which will be 2. A and B, maximum of these two, which will be 2, because both the elements are same. And A and A. Okay, interestingly, they both are same. So now what we'll do, we will take the diagonal element and add 1 in it, so it will become 3. So as a result, we will be returning. So assume that this is called DP. Okay, this array is DP, so we will be returning the element in the first row and first column as our answer, because obviously like you will get the largest subsequence value in it. Programmatically, this is how we will be writing it down. So if the character at text1 and character at text2 are same, then what we are doing, we are taking the diagonal element and adding 1 in it. Okay, if not, we are taking the, so same row next column, this will be element at the right side, and row plus 1 column, so the element below. Okay, so take maximum of the right element or the below element. So this is the complete logic which we'll have to implement. Let's check out the code now. So this is the code, like I think this is 9 or 10 lines of code which will do the job. So first what we have done, we have defined the DP array, and if you see what we have done, we have kept the length of it, we have increased the length and breadth, or number of rows and number of columns of the array by 1, because we need to have that base case, right? For example, in E and E we were looking at the diagonal element, it should be there, otherwise we'll go out of bound. So that's why we have one extra row and one extra column in it. Next, what we are doing, we are just iterating the indexes of the DP array. So we have used row and column. Okay, for that, at rows we have text1, and at columns we'll be traversing text2. Okay, and like as explained in the explanation, we are starting from the bottom, right? So that's why we have this notation. Now, if the characters are same, like the character at this row and column are same in text1 and text2, then what we'll do, we will update the value of the DP array with 1 plus the diagonal element. Otherwise, what we were doing, we were taking the maximum of right element or the element below the current index or the current position in the matrix. Okay, and at the end we are just returning the first element of the DP array. Okay, so let's check out the test cases. So as you can see, the test cases got cleared. Let's submit it for further evaluation now. And the solution got, okay, it is taking some time. Yeah, so the solution got accepted, and as you can see, like we have performed very well. We have outperformed 87% of the submitted solutions. So yeah, this was the solution, guys. Thanks a ton for watching out the video. Stay tuned for the upcoming ones. Don't forget to like the video and subscribe to the channel. Thank you.